Alright, so my belt sander absolutely sucks. The flat platen is not flat, it is also very small, it is weak, it doesn't have a proper work surface. Oh, and it doesn't turn on.
Bruh.
Yeah, I'd say it's time for an upgrade. Alright, so I did some 3D doodling and I came up with a pretty cool design. Wait, let me... Yeah, this is it.
This is what I came up with. It's a pretty standard design, similar to 2x72 belt grinders. But I live in Europe, so I made my design for 50x2000mm belts. It's a flexible design. It can run different belts of different lengths, the platen can rotate, the platen can also be completely changed out for other attachments. All in all, it's much better than my old crappy belt sander. I based the design mostly on the steel I could find on the scrapyard and the stuff I had available, because I wanted this project to be relatively cheap. I'll tell you the total cost at the end of the video. But let's stop talking and start cutting some metal. I started with cleaning and cutting the steel for the main frame. The main frame consists of the holder tubes and the pivot arm for the tracking wheel. After cutting all pieces, some holes needed to be drilled. These holes need to receive thread. For that, I welded some nuts on top of the holes. I didn't have any compatible square tubing, so I had to weld the holder tubes myself. Using some professional shims, I got an acceptable fit. These tubes fit around some stainless steel square tubes I found on the scrapyard. With the pivot arm welded on, the main framework is almost done. To finish it, I welded the front leg on. Let's continue with the flat platen. The platen itself is nothing more than a steel plate, of which I rounded the corners. The most complicated part of the platen was the side panel. I used a template to mark the holes for drilling and then proceeded to cutting and filing. This took a good while. For the final platen assembly, I needed some more pieces, which I also cut out and drilled. I also needed to make my idler wheels. I wanted to make them from wood, as I don't have a lathe. Of course, I used the worst hole saw I could find to cut a buttload of discs. I drilled a hole through all the discs for the bolt. The bearings needed a little wider hole. The discs were glued together, and for some extra strength I used some screws, because I don't want my wheels to explode. Now, because of my terrible hole saw, I had to sand. A lot. When I was finally happy with the profile, I finished the wheels with CA glue for a stronger surface. For the final assembly of the wheels, I also used a steel tube between the bearings. This is to prevent the clamping force from going through the bearings and breaking them. For the tracking wheel, I basically did the same thing, but I gave it a round profile. Now back to the platen. We can finally assemble it using the idler wheels. Using the wheels, I could align the platen and weld everything in place. With the main frame and the platen done, it was time for the actual arms of this machine. The lower arm is just a long piece of tubing. The upper arm is slightly shorter and has a few holes for the platen. To tighten these arms, I cut some thread and made handles for them. These threads fit in the nuts on the frame and tighten the arms. The pivoting arm is slightly more complicated, as it requires the adjusting mechanism for the tracking wheel. First step was to cut the arm to length, to cut some room for the mechanism and to drill a hole at the pivot point. Next was the actual adjusting mechanism itself. I cut the required pieces, drilled the holes and welded it together. It pivoted around a piece of thread, which also had to be cut to size. To make the adjusting mechanism actually work, I quickly made a wooden handle and welded a long nut to the arm. When you turn the handle, the tracking wheel pivots and adjusts the belt. Of course, I also have a motor. This needs to be mounted to something. So let's continue with that. The motor mount is made of a few simple tubes with holes in them. For the actual motor, I got this bad boy. It's a 2 horsepower motor that runs on 220 volts. I needed this because I don't have more than one phase in the house. It's 2850 RPM and I cannot change the speed. That is the downside, but it only cost me 30 euros. Now, to actually move the belt, I also need a drive wheel. A drive wheel is a little bit more complicated because it needs a solid connection to the motor shaft. Only wood wasn't gonna do it. Luckily, the motor came with a coupling. I butchered the coupling and I kept the shaft connection. To convert the rotations of the shaft to the wheel, I needed a keyway. I drilled a hole and filed until I had a keyway that fit. Of course, I also need a key. I quickly made one that fit both the motor and the coupling piece. The coupling piece also had a screw for tightening, which I could use to tighten it to the shaft. The drive wheel itself was made from wood. I cut a few discs and drilled some holes. Then came the tedious task of making the coupling piece fit snugly in the wooden discs. I also made sure to file a groove so I could access the tightening screw. When I was happy with the fit, I glued it all up using wood glue and epoxy. To add some strength, again I used some extra screws. To get the proper profile of the wheel, I attached it to the motor and used files and sandpaper to even it out. I attached the motor to its mount and used it to line it up with the main frame. The mount was welded to the frame and the first test could be done. I assembled the whole thing and turned on the motor. It looks pretty promising. With the machine working, it just needed some final details. First of all, a stable foot. I drilled some mounting holes and welded 2 plates of steel together. This is plenty stable without mounting, but if I want to mount it, I can, because of the holes. Secondly, a solid work surface. I cut a nice piece of steel plate to size. I welded it on the lower working arm and reinforced it with some extra steel. To finish the belt sander, I only needed a way to keep the belt under tension. Because I want the machine to be as flexible as possible and control the tension in each position, I used a small spring with a piece of chain. The spring provides the correct tension, while the chain makes it possible to provide this tension in different positions. And there we go! A belt sander made completely from scratch. Time to test it out. I ground a piece of mild steel for the test, and I could already tell that this was much more powerful than my little dad sander. Now that I'm using it, let me show you its features. The platen arm can be set to the correct length. The work surface can be easily installed. The platen can rotate both ways. And also, the tracking wheel can be adjusted by turning the handle. When it was already done, I was given the opportunity to make aluminium idler wheels. So, of course, I took that opportunity. I'm going to put this machine to the real test when I make my next knife. That'll be in a later video if you want to check that out. Now, I promised that I would tell how much it cost me. It is an estimate, but all materials together cost me around 165 euros. This is without the wood for the wheels because I already had that. A big portion of this money went to the steel from the scrapyard. But this is for everything I bought. I do have a lot of steel left. I think this price is pretty neat for a functioning belt grinder. Of course, the build quality is lower and my motor doesn't have a variable speed, but it's definitely better than my old belt grinder.
Well, that was by far my biggest project yet. I am very happy with the result. I hope you enjoyed the video. If you have any feedback, please leave it in the comments below, and I'll see you all next time. Goodbye.